Good evening, my fellow students. Glad to have y'all all back watching with me tonight, and this is our last time this semester before winter break, so it's time to get down. With that being said, I will once again be answering some of the questions that are based off the homework assignment you guys are given this week. So let's not waste any time. Let's just get right into this. Alrighty, so first, we're going to start off by looking at the second question. That is about creating a scenario that involves using a graph to create a question about it. Basically, let me explain. For the first one, the equation here is y equals x over 2. Now, based on that, I took those words and made a statement, made a question out of it. In a college class, fully participating in a discussion board earns you 2 points. You can read the rest of that if you want, but basically, it's just something as simple as taking the numbers and creating a problem out of it is what it is. So we know our equation is x over 2. So let's just plug in a couple values here and see what happens. First, let's start with 2. We just plug it in. 2 over 2, that is equal to 1. Then we can do it with another value. Let's do 4. So 4 over 2, well, that is equal to 2. Now that you have those numbers, we will plot them on a graph. Now, when we get to the end, you will have to do this on paper, but for now, we're going to keep things simple. Now I'm gonna cheat a little bit myself and use a little graphing calculator. It's okay for right now while we're learning it. So let's put that in. Y is equal to x over 2. So we start off with 2, 1. We got 2 with x, and the answer turned out to be 1 with y. So you can see that here. It's about 2, 1. And likewise, we go over here to 4 in the x, and we get 2 in the y. So as you can see here, your graph would look something like this. Now, for the next problem, let's do this again. Negative x over 2. Very similar, except the graph's going to be flipped. It was going this way, and now it's going to go down. The slope is going to flip pretty much. So here's my example. Once again, I'll let y'all read it. And then let's work on this. So negative x, let's just take, if we use the same numbers, it's going to come up the same. It's just that instead of y being positive, y will be negative. And we'll reflect that here on our graph as well. So as you can see, our graph was going this way. Now it's going this way. But in the end, the work still comes out pretty good. x2, y is now negative 1, whereas it was 1 earlier. And likewise, y is now negative 2 when x is 4, whereas it was on the positive side, it was up here when we did it. Moving right along. Now we change things up a bit. Our equation now is 10x. Excuse me. So it's a little more daunting, but we can get through it. So let's take our equation. Let's just plug in a number. 10, let's say x is 2. Well, just do the math. 10 times 2. 10 plus 10 is 20. Likewise, 3. 10 times 3. 10 plus 10 plus 10. That is equal to 30. On a graph, it would look like this. Ooh, I'm going to have to actually zoom out here so y'all get a better view. See? So here's 10. That is what we get when x is 1. 20 on y is x on 2. 33, 44, so on and so forth. Now, for the final equation, this one is one of the most trickiest, but the thing I want you guys to realize is that the graph, since we're doing squared numbers now, you will get numbers that are going to be positive no matter what. It's just that it's going to kind of reflect itself on the graph. And you'll see what I mean here in a moment. Now, let's get some points and we'll kind of plot this out. So Let's say y is equal to x squared. We plug in x is 3. Now 3 squared is the same as 3 times 3. That's 9. And I said 4 here, but I'm going to change that up to help illustrate my point. Let's say x is negative 3 instead. That means it's negative 3 squared, and that's the same thing as negative 3 times negative 3, which is equivalent to negative 9. Now, you'll see how this makes sense when I do the graph. See how it kind of repeats it's a parabola. So as a result, no matter what you do, you're going to kind of repeat yourself here on the y value, because you get 100 on y when you do 10 squared, whether it be positive or negative. So it kind of just repeats itself. And that's the case here for some of the smaller numbers too. So that's what you're going to get when you work with squared numbers, no matter what. Now let's move on to question 3. Now for this one, I want you guys to look at a shape like this. Divide it up into parts. Realize that these parts represent fractions of the whole figure. And from there, I want you guys to notice that and use that to figure out how much of something like this. So for example, we have the square here is divided into 4 parts. So that means each part of this is 25%. Now by eyeballing, you look at it and it's kind of, the shaded part kind of stops right at about the 50% mark. So half of this fourth is going to be 1/8, and that means the shaded portion represents 1/8 or 12.5% of your entire figure. Once again, let's do another one. For this one, we notice the square is divided into 9 parts this time, so we're working with 9ths. We have 3 filled up already, so that means we're going to have at least a third. Once again, look at this square here on the upper left-hand corner of the figure. See, it's once again, it kind of stops right at about the halfway mark. So as a result, we're going to be looking for a number between something between a 1/9 of a number. Now, what's half of a 1/9 is what I did. So we want to split a 1/9 in half, and you get 1/18, or about 5.5% repeating. So with that in mind, I take the 3 wholes, the 3/9, which translates into 1/3, and then added 1/18 to them. And that's how I got the problem. Now, to get these to like terms, I multiplied this, basically extended this out, and equated it to what it is in the form of 18ths. So 1/3, that's the same thing as 6/18, so it just becomes 6/18 plus 1/18, which gives you 7/18, or about 38.8% of your figure. And finally, here's your shape right here. Now, once again, it's easy to like, whoa, what is this shape? I've never seen anything like this before. But if you give it the eyeball test, you can actually kind of see that you actually could put this red portion here. If you flipped it around, you could actually replicate it here on this white portion. So as a result, this represents 50, the shaded part here represents 50% of your entire figure as well. And that's the key, is just to look at the shapes, kind of pay attention to the outlines, see how much is being represented in chopped up portions, whatever, and then once you have that, you can translate that to what should be relatively simple fractions, and that will give you your answers. And that would be the key to solving this one. Now for one more question. Now for this one, this is about taking a base shape and using smaller shapes to represent how this relates to a base shape. So for example, if we take our hexagon and play around with smaller shapes, we will see that the smaller shapes are about going to fit in this hexagon. Allow me to demonstrate. Let's start with 2 trapezoids. Well, 2 trapezoids, if we were to put them into our hexagon here, draw them in there, then you'll see that they will fit into the hexagon if you put the 2 of them together. So as a result, a trapezoid represents a half, 50% of a hexagon. Once again, this also repeats itself with the triangles. A triangle is about 1/6 or 16% of a hexagon. So as a result, you can put it in there 6 times to get your hexagon. And I do apologize for the quality of this drawing. So next, we have squares. Now this is where it gets interesting, because you get to some of these shapes like the squares that don't fit in perfectly. What I want you guys to do is to point out I want the exact number of shapes. Like, for example, about 2.6, if we were to round to the nearest tenths, is how many squares will fit in here. But when you're drawing it out, I'd expect you guys to draw in 3 squares and try to have one of them poking out. I did that to the best of my ability here, so I hope that makes sense. But basically, just draw 3 and have one stick out. And a square, when we look at it, it's equivalent to 77/200 or 38.5% of a hexagon. Next, we have tan rhombuses. Again, much like with the squares, you're just going to want to overfill it, but with as little hole integers as you can. Like, here we have 5.2 tan rhombuses that will go into this hexagon. So that's in between 5 and 6. So once again, put 6 in there, but you want 1 to stick out. And you'll also calculate that a tan trapezoid is 24 out of 1/25, or 19%, a little over 19% of a hexagon. And last but not least, we have 3 blue rhombuses. Now this time, it comes out to, they will fit in here equally now. We're going back to the even integer shapes, because a blue rhombus mathematically is about 1/3 of a hexagon. So as a result, if we stack 3 of them in there, it should come in there to be about 3 blue rhombuses being the same as a hexagon. Again, I apologize for not being able to put it in there fully. It's tough to do, but I'm getting the hang of it. And I think that's going to serve as a wrap-up for my lesson tonight. Thank y'all for paying attention, and if y'all have any more questions, please do not hesitate to contact me. With that being said, I am going to be wrapping up, so thank y'all so much, and I'll catch y'all real soon.